Have you ever looked up at the night sky and felt a sense of wonder? Have you ever felt that pull of curiosity? Or perhaps you've watched a simple leaf fall from a tree, spiraling gently to the ground, and wondered why it moves just so. These questions come from the grand scale of the cosmos, and from the intimate dance of everyday objects. These are the very heart of physics. Physics is simply the story of how everything works. It's the rulebook for the universe. It explains the motion of planets. It explains the heat of the sun. It explains the light from a distant star. It explains the tiny particles that make up you and me. It's the quest to understand the fundamental principles that govern reality itself. This journey will peel back the layers of our world, revealing elegant and often simple ideas. We will not be diving into complex mathematics, nor bewildering equations. Instead, we'll explore core concepts using plain language and clear step-by-step thinking. We'll cover motion, forces, energy, gravity, and the building blocks of matter. Why care? Because physics is everywhere. Prepare to look at the world in a new way. At its most fundamental level, physics begins with the study of motion. Motion is simply the act of an object changing its position over time. Think about it. A car driving down the road, a planet orbiting the sun, an electron buzzing around an atom. To describe this movement, we use concepts like distance. Distance tells us how far something has traveled. Speed tells us how quickly it covered that distance. If you know how fast something is going and in what direction, you have its velocity. Motion is the very language of change in the physical universe. Imagine watching a train travel along a straight track. Note its starting position. As time passes, its location is different. This change is motion. Measure the distance it covers. Use a stopwatch to measure the time it took. Divide distance by time to get average speed. Example: a bowling ball rolling down the lane toward the pins. A change in direction, even at constant speed, is acceleration. Activity: mark 1 meter, time your toy car or marble, and compute speed. Try a gentler push and a harder push to compare times and speeds. A simple calculation with big implications. If motion is the what, then force is the why. An object doesn't just start, stop, or change direction on its own. Something has to make it happen. That something is a force, simply a push or a pull exerted on an object. Kick a football, lift a bag of groceries to counter gravity. Both are forces. To move a resting book, you must apply a force. Push it, and it slides. It slows when you stop pushing because friction opposes motion. Balanced forces. No motion. Unbalanced forces. The rope accelerates toward the stronger pull. Pushing near the hinge is hard. Near the handle is easy. That turning effect is torque. Over 300 years ago, Isaac Newton formulated 3 simple laws describing force and motion. First law, inertia. Objects stay at rest or move at constant velocity unless acted on by an outside force. In space, with almost nothing to slow it, a satellite keeps moving. Second law links force, mass, and acceleration. Force equals mass times acceleration. Bigger mass needs bigger force for the same acceleration. Harder to push a car than a bike. Third law, for every action there is an equal and opposite reaction. Forces come in pairs. Push a wall. It pushes back on your hand equally. A rocket pushes hot gas out. The gas pushes the rocket forward, propelling it skyward. Try this. Blow up a balloon, don't tie it, then release. Air jets out. Action. Balloon zips off. Reaction. It accelerates. Second law. Together, the 3 laws give us a precise language for change. If forces are what cause change, then energy is what is required to make that change happen. Think of energy as the currency of the universe. You spend it to do anything. Energy is the capacity to do work. Work is applying a force over a distance. Energy isn't a substance you can hold. It's a property of objects and systems. It comes in many forms: kinetic, potential, chemical, thermal, Electrical. It can be converted from one form to another, but never created or destroyed. Kinetic energy is the energy of motion. Faster and more massive means more kinetic energy. A speeding truck carries a lot of kinetic energy. Potential energy is stored due to position or state. A book held high has gravitational potential energy. Let it go and gravity converts potential into kinetic energy. At the top of the swing's arc, speed is zero and energy is all potential. As the swing descends, potential becomes kinetic, peaking at the bottom. Rising again, kinetic converts back into potential, a continual transformation. Try a yo-yo, dropping unwinds and spins, potential to kinetic, then winds back up, kinetic to potential. You're witnessing conservation of energy in action. Gravity keeps our feet planted, holds the moon to Earth, and keeps Earth in orbit around the sun. Gravity is the universal attraction between any two masses. Any two objects attract, but for small masses the pull is imperceptible. Gravitational strength depends on mass and distance. More mass or less distance means stronger pull. Astronauts are still in Earth's gravity. Orbit is continuous freefall around the planet. Apple and Earth pull each other, but Earth's vast mass makes its acceleration negligible. Activity: drop a heavier and lighter object together. They land virtually at the same time. A feather is slower only because air resistance matters more. A wave is a disturbance that transfers energy without transferring matter, like ripples on a pond. Sound travels through matter via compressions and rarefactions. Light is an electromagnetic wave, disturbances in electric and magnetic fields. It needs no medium and races through space at about 300,000 kilometers per second. Raindrops act like prisms. Refraction bends colors by different amounts, violet most, red least, spreading white light into a spectrum. Home activity: place a glass of water in direct sunlight and catch the transmitted light on white paper. Adjust until a small spectrum appears. You're splitting sunlight just like raindrops do. Light carries energy and information across the cosmos. Everything you can touch and see is made of matter, built from tiny atoms. Atoms join to form molecules. Water is 2 hydrogen atoms and 1 oxygen atom. Substance properties depend on atom types and how they connect. State depends on energy and motion. Solids vibrate in place. Liquids slide. Gases move rapidly and spread. Add energy. Ice melts to liquid. Keep heating and it boils into gas. Observe at home. Watch an ice cube melt, or dissolve salt in warm water as ions mix with molecules. Electromagnetism shapes our modern world. A moving electric charge, a current, creates a magnetic field around it. This powers electromagnets and electric motors. Conversely, a changing magnetic field induces current, the basis of generators in our power grid. A compass aligns to Earth's vast magnetic field, a planetary scale demonstration. With supervision, complete a simple circuit. Battery bottom to foil, bulb tip to battery top, other foil end to bulb casing, the bulb lights. Motion, forces, energy, gravity, waves, matter, and electromagnetism, the hidden laws orchestrating the dance of existence. Let curiosity lead you further.